Okay, a couple orders of business before we get started. Bad news first, no class next Tuesday. Don't act excited, it makes me mad. Okay, no class next Tuesday. I don't have your exams done obviously yet, but I'll try to get them done by next Thursday and get them back to you. I took a quick look at them and looks like you guys did really well. I expected you to do well and they look good. So we'll see how it goes. But I'll try to get those back to you by next Thursday. About a half hour ago, I sent you an email with the third lab. It's on geologic maps. It's pretty straightforward, but I wouldn't be surprised if you had a few issues. So if you start doing the lab and have some questions, just email me. I won't be around this weekend, so you'll have a hard time reaching me this weekend, but I'll be around next week, but not Tuesday. So send me, I'm giving you 2 weeks, so it's due 2 weeks from today, which I think is the 22nd. So yeah, 2 weeks from today, that lab will be due. It's not long in terms of questions, but it might take you a little time and a little thinking. Hopefully you'll enjoy it. I think you will. Okay, so last class we were talking about soils, and we will finish up soils next week, but I don't know. I get bored doing all sciencey stuff sometimes, so I like to switch it up. So we're going to switch to a topic that we discussed just a real brief bit a couple weeks ago, and I told you I would come back to it and spend some more time. So I like this chapter. I end up teaching it in most of my classes, and it's relationships between geology and your health, okay? So looking out at you guys, you're young, seem to be, you're all alive during a pandemic. That's good. So I'm guessing you guys take care of yourselves. You're here with your masks on. What do you do to keep yourself healthy?
Sleep.
Get your sleep. What else? Drink your water. I see you have a water bottle. What else? Eat. What? And so you're talking about things you should do to be healthy, right? Sleep, drink your water, eat well, get some exercise. What about things you shouldn't do to be healthy? Don't lay around all day. Don't be a slob, right? What else? Are there habits that you probably shouldn't have to stay healthy? Such as? Not sleeping, smoking, right? Shouldn't smoke. Don't do heroin. You know, stuff like that, right? And those are the things that if you listen to popular media, watch TV shows, take a nutrition class, that's what they tell you. You got to do this to be healthy, right? How many of you have ever heard, oh, you got to live over the right rock type? You got to live on the right rocks and soils to be healthy. Well, what I'm going to convince you today of is that your health is very much tied to the earth. And hopefully you'll get a new appreciation for that today. You can do all the right things. You can eat, you can not smoke, you can get your sleep, you can have a great diet, you can go vegan, and you can be extremely unhealthy if you live over the wrong rocks and soils. So that's what we're going to get into today. And to sort of set it up, we're going to think about the human body from a chemistry standpoint. The human body is pretty simple. 99% of you, me, your mom, your dad, siblings if you have them, roommates if you have them, we're all made of the same stuff. And 99% of all of us is just 6 elements. Anybody know what the most common element in your body is? Want to take a stab? Most people guess carbon. Because a lot of our cell material is carbon. It's in the top 6, but actually the most common element in your body is straight up oxygen. Oxygen, carbon, hydrogen are the first 3. You've probably heard about 60% of your body is water. So hydrogen and oxygen. So these first 3 oxygen, carbon, hydrogen, that kind of makes up your soft stuff, all your cellular material. And then the last three, nitrogen, calcium, and phosphorus, makes up the hard stuff, your skeletal system. But a human skeleton doesn't weigh much. It only weighs 10 to 20 pounds. So you're mostly the soft stuff. So you're mostly hydrogen, carbon, and oxygen. 99% of you can be taken up by those 6 elements. But I'm guessing you can think of elements not listed there that you must have to stay alive. Can you think of any? Iron. Yeah, you need iron in you, right? Iron is an essential part of hemoglobin in your blood. Allows oxygen transport. If you don't get enough iron, you're dead. You're dead as a doorknob, okay? So there is some remaining you, 1%. That remaining 1% are called trace elements. Trace because they exist in your body in trace amounts. We typically measure these in parts per million or parts per billion. Now, most of your body, 99%, oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus, but there are a boatload of other elements in your body that are there in tiny amounts. You have some gold in you. You all have gold in you, just a little bit. Measure it in probably parts per billion. You have silver in you, platinum in you. You have mercury in you, lead. If you look at the periodic table up on the classroom over there, just about everything on that list is in you in really tiny amounts. Now, some of those things your body really needs to survive. Other things, not so much. They're just there. But we're going to talk about how these things actually behave in your body. Because many of these trace elements are absolutely essential for you to function as a human being. Without them, you are dead. And there are some trace elements that your body doesn't want much of. You do not want lots of mercury in you. You do not want lots of lead in you. You don't want lots of uranium in you. Your bodies can handle tiny amounts, but it can't handle too much. And we'll get into how these things function in your body on the next slide. Any questions so far? Okay, I'm going to put up a little chart here, okay? Over on the left, it's going to be the element. That second column is average body concentration. How much of this stuff is in the average human? Third column is its function. What does it do for you? How does your body use this element? And then this last one is kind of an interesting category. It's called deficiency diseases. If you don't get enough of that element, what happens to you? All right, so when I asked you earlier to name an element that wasn't on the top 6 of the list, somebody said iron. So iron is in you in small amounts. We said a minute ago its function is to make hemoglobin work properly, and hemoglobin is the molecule in your body that takes oxygen and delivers it to your cells. You guys know the disease that you get if you don't have enough iron? Okay, so the element is iron. The average human body will have about 60 parts per million, or out of every million elements in your body, out of every million atoms, 60 of them will be iron. So they're in pretty tiny amounts. Its function is oxygen transport. So if you don't get enough iron, your body isn't going to transport oxygen well, and the disease that develops from that is anemia. So if you don't get enough iron, you're going to be anemic. And being anemic sucks. My wife dealt with anemia for a while. It was not pleasant. She had to take iron supplements. She wasn't getting enough in her diet. She's not a big red meat eater. She likes her veggies. I've never dealt with that problem. I like eating red meat. Maybe not to, it's great to not get anemia, but red meat has other effects that maybe aren't so good. So I got to deal with that. Iodine. We talked about iodine. I think that's how we actually ended up here. We were talking about something in class a few weeks ago. Iodine came up, and we ended up talking about the deficiency disease, goiter. We'll come back to this in a minute, talk about iodine a little more specifically. Iodine, 0.2 parts per million, or 200 parts per billion. You could think of it that way. So out of every billion atoms in your body, 200 of them are iodine. That's not very much. But if you don't have those 200, you can be really sick. Iodine is absolutely essential for your thyroid to work properly. Thyroid is one of the glands that controls metabolism. And if you don't get enough of this stuff, you can get a pretty nasty disease called goiter. Some of you looked it up last class. I have a picture that's coming up. You do not want this stuff, okay? And here's some other ones. You can write these down if you want. I don't care. I'm not going to ask you about any of these specifically. Copper, 1 part per million. 1 out of every million atoms in your body is copper. Your body produces enzymes. Enzymes allow chemical reactions to occur in your body. And one of the chemical reactions that copper helps with is cholesterol. The processing of cholesterol. Without copper, your cholesterol levels can spike. That 1 atom in a million can actually keep you healthy. Fluorine. When I was a kid, they used to put fluorine or fluoride in our tap water. It was supposed to help with bone growth. Also had some side effects, so most places don't do that anymore. But they add fluorine to toothpaste. And if you don't get enough fluorine, it can result in bone growth problems, tooth decay. You need some fluorine in your body. Average concentration, about 37 parts per million. You see chromium there, used in insulin. Cobalt and zinc, important in metabolism. So even though, again, the point of this, tiny amounts can keep you healthy. Just 1 atom in a million. If you have it, you're good. You don't have it, you're not good. So, bottom line is, your health is very dependent on getting some of these trace elements into your body. We'll talk about how we get them into our bodies in a second. But even though they're there in tiny amounts, got to have them. Okay, we're going to spend a little time with some graphs that should illustrate how these trace elements act in our body. And we have three different cases. There's three possibilities for how a trace element is going to behave in your body. This first one is actually a somewhat rare case, but nonetheless important. In this first case, there's no known need for the trace element in your body. Your body doesn't need this stuff at all. So the way these charts are going to work is if you're on the left side of the chart over here, it goes from no dose. In other words, you don't have any in your body. And as you move to the right, you increase the dose, or you increase the amount. So if you're way on the left, you're not getting any. If you're way on the right, you're getting a lot. And then the y-axis, if you're above the line, you get a benefit from that amount. And if you're below the line, it's harmful to you. If you're on the line, it doesn't hurt or help, okay? So in this case, there's no known need for the trace element. You're never going to get a benefit, okay? But your bodies can handle small amounts. You all have a little bit of lead in you. You all have a little bit of mercury in you, but our bodies can handle small amounts. So if you're not getting any, you're not going to be hurt and you're not going to be harmed. Now let's get a little in you. You can handle a little bit, right? It's not going to help you, right? There's no need for this in your body, but a little bit's not going to hurt you. Okay? Let's just increase the dose, increase the dose, increase the dose. At some point, what's going to happen? It's never going to help you, right? What happens if you take too much? What if you get too much lead? Too much mercury? Yeah, at some point, what happens is when you increase the dose, throughout this range, you're okay. It's not good for you. It's not hurting you yet. But at some point, it becomes toxic if you get too much. What happens to your health when you exceed toxic levels of things? What happens is your health declines, right? So, you're not too bright. You get up every morning and you eat a bowl of lead paint chips. And then next day you do the same thing. Next day you do the same thing. And stuff starts to accumulate in your body, right? At some point, you're going to get sick from this, right? But you're an idiot. You keep eating your bowl of paint chips every day. What's eventually going to happen to you? You're going to die. X marks the spot. Yeah, you don't want this. Now, where these toxic levels occur really depends on the individual. I might be able to eat a few more paint chips than you guys. Or maybe you can eat a few more than I do, depending on your general level of health, your genetics. We know that lead is especially bad for small kids and old people. I'm not old. I keep telling myself every day. But a child may have toxic levels maybe here. Really fit person may have toxic levels over here. But at some point, take too much of this stuff, it's going to get toxic, which means you start going to have ill effects to your health. And if you don't back off, you're going to die. Okay, so that's the first case. No known need for the trace element. Your body doesn't need it. It can handle small amounts, but eventually it's going to be toxic. All right? The next case is a little different. In this case, you need it. It's essential. You got to have this stuff. If you don't have it, you're going to be sick. But in this case, modern science hasn't detected that you can OD on this stuff. Something like vitamin C or water-soluble materials. How many of you take vitamins? What happens when you take too much vitamin C? How do you know when you've had too much vitamin C? Can you tell? Yeah, you have day glow urine. Your pee is like bright yellow and orange if you take too much of this stuff. But your body's just getting rid of it. Your body's simply dissolving the excess and you're getting rid of it in your waste products. So you don't get sick from it. You can eat a handful of vitamin C if you want. You're just going to, for lack of a better term, you're just going to piss it out, you know? But you need it, right? That's why you're taking it. Okay? So if you're not getting any, if you're over in right here, no dose, are you going to be healthy? No, so you're going to be down here in the harmful range, right? If you don't want to be harmed, what do you need to do? Take some. Eat an orange. Eat a tomato. Pop open your pill bottle and take out your vitamin C supplement. So as you increase the dosage, eventually your health improves. But this isn't one of those things where, hey, if I just take more, I'm just going to feel better all the time. If that was the case, we'd all be eating pounds of this stuff, right? At some point, it doesn't do your body any more good, right? Because your body just pees away the excess. So what you end up with is you kind of stay at a good level of health. If you don't have enough, it's called a deficiency disease. Anybody know the disease you get when you don't have enough vitamin C? Scurvy, yeah. Scurvy sucks. You don't want scurvy. So yeah, if you're not getting enough, you'll have scurvy. If you don't want scurvy, increase your dosage. Eat your orange. Eat your tomato. Take your vitamins. But once you increase your dosage, at some point, more is not better. But more is not worse in this case either because there's no known overdose. So what you end up with is you kind of stay at a maximum benefit. As it turns out, there's not a lot of elements or molecules that work this way either. These first two cases are a bit on the rare side. The last case that we'll get to is how most things act in your body. But I'll let you finish up your notes here. Okay, last case. The trace element is essential, but you can overdose on it. Okay? So it's toxic in high doses. So it's kind of a conglomeration of the first two. You need it, but if you get too much of it, you're going to be sick. So you got to get the right amount. Can't have too little, can't have too much. And as it turns out, most trace elements in your body act this way. Iron acts this way. Calcium acts this way. Potassium acts this way. Think of potassium. I don't know, you guys know what potassium's good for?
Cramps.
Yeah, if you don't get enough, you can have muscle cramps. If you get too much, you get toxicity and you can die. Water's interesting. Water behaves this way. And most people know about what happens when you don't get enough water. What's the condition when you don't have enough water in your body? Dehydration, right? You can die from dehydration. But what a lot of people don't realize is you can also drink too much water. It's possible to drink too much water. It's a condition known as hyponatremia. Endurance athletes had trouble with this for a while. If you go out on you do one of these ultra marathons or an Ironman event and all you drink is water, and you drink a lot of water, you can actually OD on the water. It upsets the balance of salts in your body, and your body can shut down, your kidneys shut down. That's where Gatorade came from. It's replacing the salts along with the water. Just water itself, you can dilute your body to the point where it won't function properly. So how's that going to work on our graph here? Let's say you don't get any water. Are you healthy? No, so you're going to be down in this range, right? If you want to be healthier, what do? Drink water. What's going to happen to your health if you drink your water? Yeah, it's going to improve, right? But like with vitamin C, more isn't always better, right? You need your 8 glasses or 12 glasses. I don't even know anymore what the amount is. But at some point, you have a good amount, right? And you can drink a few glasses more and be okay, right? But it doesn't improve. But if you get to the point where you drink too much, what starts happening to your health? It decays. It becomes toxic to you. What happens to your health if you keep taking in water once you hit a toxic dose? Your health gets worse. And if you just keep drinking water, you're eventually going to die. Now, this is how most things behave in your body. You want some, but not too much. All right, any questions on how these things behave? So it's this last one that covers most of the things. All right, so what does this have to do with geology? Well, as it turns out, the ultimate source for a lot of these trace elements is the ground. One thing we do as geologists is we can help identify and measure potential sources of trace elements out in the natural world. How can you get trace elements into your body? We've talked about a few ways already. If you want more vitamin C, what do? You eat something, right? Can you get trace elements from drinking stuff? Water, remember, is H2O, but it has dissolved stuff in it. Hard water has lots of calcium and magnesium. That stuff's actually good for you. You can get some from your water. And you can actually breathe in some trace elements. Our air has lots of stuff in it. Most of it's nitrogen. Most of the rest of it is oxygen. And then about 1% of the air we breathe is all sorts of stuff. Carbon monoxide, sulfur gases, fluorine gases, organic gases, radioactive gases. And when you breathe that stuff in, you get those elements in your body. A fair bit comes from water. Some of the stuff in water is good for you. Some of the stuff in water has the ability to be toxic at really low levels. Especially some human added things to water like benzene. That can be really damaging. High rates of cancer. So some of these trace elements and molecules, things we definitely don't want. But most of the trace elements you get comes from your food. And ultimately, Okay, if I eat cow, I'm getting all the trace elements that are in the cow. A lot of it's red meat. I'm going to get high levels of iron. I get some other elements as well. Where did the cow get its trace elements from? Eating grass. Where did the grass get its trace elements from? The soil. Yeah, so the soil is the ultimate source of the trace element for the grass, the cow, and then later meat. So the soil is where the trace elements come from. And that's the link to geology. So if you're in an area, we used this as an example a couple classes ago, that doesn't have much iodine in the soil, then the grass isn't going to have any iodine. And all the food that eats the grass isn't going to have much iodine. And ultimately, if you live there, you're not going to have much iodine. So your trace element is highly dependent on the rocks and soils and any sort of human use that might occur in an area. If you're in an area where a company is illegally dumping benzene, which has happened in California, Pacific Gas and Electric was sued, well, it's been almost 30 years ago now, I think, for dumping benzene into the water, and people got really sick. If you ever saw the movie Aaron Brockovich, that's what that whole movie is about. Legally dumping benzene and then that being sucked up into water and eventually into people. So your trace element is highly dependent on the rocks and soils in your area. But not as much today as maybe 100 years ago. Why? Because you don't get, because 100 years ago, people used to get the food just from their area, the food that was grown in their area. So if there was no iodine in the soils, these people didn't get any iodine. Now where do you get your food? You go to King Soopers, you go to Safeway. You're picking up an avocado from Ecuador. You're picking up an orange from Texas. You're picking up lettuce from the Central Valley of California. There's different soils in those areas with different trace elements. So actually you get a much better trace element portfolio today than 100 years ago. And we have things like vitamin supplements, right? Why do you take vitamins? Vitamins and minerals. It's to balance out if you're not getting enough of these things in your diet. If you're just eating chicken nuggets every day, you might not be getting enough of a certain trace element that isn't found in chicken. So supplements make up for our diet, water, air we breathe, not providing it to us. I have a friend of mine, he's in his 60s, he won't eat vegetables. He just won't eat vegetables. I don't know how the dude goes to the bathroom, but he won't eat vegetables. But he's reasonably healthy because he takes supplements all the time to counteract his horrible diet. It's amazing how much abuse the human body can take. It's really pretty sad, but that is what it is. Here's another way. I don't expect you to write this down, but what it's showing is different rock types. So we have different rocks. We have peridotite, basalt, andesite, rhyolite, phonolite. And if you look, here are some elements. Here's some manganese right here. And if you look, the amount of manganese is really different in these rocks. So that means the soils that develop on those rocks are going to be different as well. Some rocks have high amounts. Look at aluminum. Peridotite, really low amount of aluminum. Phonolite, really high amount of aluminum. If you lived in an area that has phonolite, your aluminum levels are likely to be different than somebody who lives over a peridotite or a basalt. Bottom line is the rocks degrade into the soils, then the plants take these elements from the soils, and then as you go up the food chain, those trace elements get passed along. So you get different trace elements depending on the rocks that are in your area, which shouldn't be a great surprise to you. All right, let's do some examples. This is an example we talked about a couple weeks ago. So back in the late 1800s, early 1900s, the northern central part of the U.S., the Dakotas, parts of Montana, parts of Minnesota, were known as the Goiter Belt. I can pretty much assure you if you go to North Dakota today, you're not going to see anybody with goiter. I've never seen a person with goiter. But it was common. It was common back when folks ate the food from their region. And these areas are very poor in iodine. Goiter is a thyroid disease caused by the lack of iodine. So it's a deficiency disease. Again, this was very prevalent in the northern U.S. in the late 1800s. That's because the rocks that occur in this area simply don't have much iodine. So the soils are very iodine poor. So anything that grows in these soils is iodine poor. And anything that eats food from that area is not going to get much iodine. It's not a disease anybody wants, but the way we combated it was to put it in something that everybody uses as a food supplement, which was salt. It's tasteless, so you can add it to salt without affecting the quality of the food that you prepare. So iodized salt, something that happened over 100 years ago, and it immediately wiped out goiter in the U.S. and worldwide, basically. It's a disease you don't see much of anymore. And it's not something you want because it looks like that. So easily preventable, but just that tiny little atom not being in your body can do this to you. Radon gas is one of my favorite to talk about because it's really important here. You know that breath you just took? It had some radon in it. Radon is really bad for you. The reason there's so much of it around here is that we're in a mountainous area. Mountainous areas tend to have a lot of granite. Granites tend to have a high level of uranium. Uranium is radioactive. What it means to be radioactive is that something like uranium is going to break down into some other elements. And one of the elements that uranium breaks down into is radon. So if you have granite, you have radon. So this is a gas that's produced in the ground, in the rocks, as uranium breaks down. So if you have a gas that's in the ground, what does that gas want to do? It wants to go up, right? It's less dense than its surroundings, so it wants to rise. And it will rise. It'll get into cracks and crevices. It'll start working its way up to the surface. And when it reaches the Earth's surface, it'll just blow away in the wind. Most of the time. Humans have a way of messing with stuff, and we do things that actually concentrate radon. So the thing about radon, it's a gas, it's radioactive, and it has what we call a short half-life. In other words, it will break down into something else really quickly. In fact, if you had a pound of radon, 4 days later you would only have half a pound, because half of it will break down into something else. That's a really fast half-life. And when radon breaks down, it sends off what physicists call an alpha particle. I don't care if you remember this, but an alpha particle is basically a helium nucleus. Got 2 protons, 2 neutrons. So radon, when it breaks down, spits these 2 protons and 2 neutrons into the environment. And that changes its chemistry, and it turns into something else. So right now you're breathing, right? So take a breath. Most of that was nitrogen. A fair bit of it was oxygen. But there was a little radon in there. But most of the time when you breathe it in, you breathe it back out before it decays. But every once in a while, one of these buggers is going to decay in your lungs. And it's going to send that alpha particle out into your lungs. And it's going to damage your lungs. These alpha particles are really damaging. Most of the time you breathe in radon, you breathe it out. But if you're in an area that has a high level of radon, you're going to take enough breaths, and these things are going to start decaying in your lungs. And it can be really damaging for your health. So, as I said before, uranium is the rock type, or granite is the rock type that has a lot of uranium, and radon is a byproduct of the breakdown of uranium. And then that radioactive gas radon will actually break down as well. So where does the health hazard come from? Well, like we just mentioned, the health hazard comes from when radon breaks down in your lungs. So what we have here are 2 homes. This is a terrible diagram, my apologies. But over here on the left is a rich person's home, well insulated. They have money. It's a well-built home. We want our homes to be well insulated, right, in the winter so that we're not spending enormous amounts of money trying to keep them warm. Over here on the right is my house. I have a crappy house. It's poorly insulated. And both of these homes are built on granite. So granite has uranium. Over time, the uranium breaks down into radon. That radon is a gas. That gas wants to move upward, right? And it will. It'll move upward. And what it'll do is, if it rises up to the surface, the wind will just blow it away. But if it rises up beneath your house, what it'll do is it will find little cracks and pore spaces in your foundation, and it will make its way into your house. What if your house is well insulated? What happens to the radon levels in your house if it's well insulated? It goes up because that's what insulation does. It keeps the air in, right? So radon is actually a problem in really well-built homes. And it's really bad in the lower levels. Basements are terrible. First floor, not so good. Second floor, better. Now, if you have a poorly insulated house, air gets in, air gets out. It can dilute the amount of gas, and the levels won't rise as high. So if you're a resident in a well-insulated house, you're breathing in a lot more radon than somebody who lives in a crappy house. And if you're in the basement, you're probably breathing in more than the people who are on the first floor. Before I came to Colorado, I lived in the Black Hills of South Dakota. They have lots of granite, lots of uranium, and lots of radon. And the college I worked at, some of the buildings had high radon levels. And in fact, they had a daycare for the students and faculty in the basement of one of the buildings, and they checked the radon level and it was off the charts. And what they had to do was put in an air exchange system. And it cost them $250,000 to do it. Radon mitigation is really expensive. And radon levels are high anywhere that you have granite. Northern Arizona is one of the worst places, especially on the Navajo reservation. They have uranium-rich sandstones, really high radon levels. The Rockies, here where we live, Black Hills of South Dakota, Sierra Nevada, Appalachians, the northeast part of the U.S., basically mountainous regions are the worst. Because they have a lot of granite, which has a lot of uranium, which has a lot of radon. So when you breathe this in, and the radon breaks down in your lungs, that emitted alpha particle kind of rips through your lungs and damages that material. It damages your lungs every bit as much as smoking does. So it's responsible for lots of lung cancer. In fact, it's the second leading cause of lung cancer in the U.S. behind smoking. And I'm going to compare radon levels to smoking here in a second, and it's rather astounding. If you don't smoke, but you live in an area with high radon, it's like smoking many packs of cigarettes a day. So how does the radon get into your house? Well, remember, radon is produced down in the ground. It rises up because it's a gas. It can move into your house through openings where there's sump pumps, cracks in your foundation. It can even get into your well water. So when you take the water and take a shower, it can come out in your shower. Anything that interacts with the ground can ultimately get radon into your house. And if it's well insulated, then it sort of traps the gas inside. Here's a map of where radon is the worst. Now they measure radon with a unit called a picocurie per liter. I don't care if you remember that name, but that's the unit, okay? If you are less than 4 picocuries per liter, that's pretty good, okay? If you're over 20, that's really horrible, and you need to do something about your house. So when I moved to Fort Collins, I was looking at homes, and when you buy a home, they require a radon test. So I had put an offer in on a home over in Fort Collins, and the radon test came back at 28 picocuries per liter, which is not uncommon for Fort Collins. So, do I want to live in a house that has that much radon? No. So what do? You either pass on the house, or you can put in an air exchange system. And these air exchange systems for homes cost in the range of about $10,000. I'll show you a photo of what they look like. And if you go over to Fort Collins, you'll see them on a lot of homes. Okay? When I lived in South Dakota, I knew it was an area that had high levels of radon, and my bedroom was in the basement. So I was kind of concerned about it. So I did a radon test there, and it was 12 picocuries per liter. So it was above the safe zone, but below the zone where you definitely have to do something. But it bothered me, so what I did is I just left the basement windows open all the time, even in the winter, just to exchange the air. How bad is it? It's bad, okay? Living in a home that has 4 picocuries per liter is the same as smoking 8 cigarettes a day. That home in Fort Collins that had 28, that was equivalent to about 60 cigarettes a day smoking. That's the damage that would have occurred just by breathing the air in my house. I don't want to smoke 60 cigarettes a day. That's a ridiculous number. That's pretty much chain smoking all day long. And here you can be doing everything that's right for your health, right? You could be sitting in this home with 40 picocuries per liter, eating your organic kale chips and drinking your 20 glasses of water and working out 2 hours a day. And you can be dying from lung cancer. So as you go forward, take this seriously. If you're in the basement apartment, get a radon test. They're easy to get. You can go over to Lowe's, Home Depot, Menards, Ace Hardware, and you can buy one of these radon test kits for about 15, 20 bucks. What you do is you just set it in your room. I usually put it in a closet. I want to know kind of the worst case scenario, so a closet has like the least amount of air circulation. So you put it in there. Some of them you have to leave for a few hours, some for a few days. Then you send it in, and they send you back what the number was. 2 picocuries per liter, 10 picocuries per liter. But it gives you a good idea of what's going on with the air you're breathing. So if you're concerned about your health, this is definitely something worth doing. If you're renting, tell your landlord you want a radon test. It's good to know. Yeah?
What other solutions are there other than that air exchange system?
Leave your windows open. You have to get the radon out and other air in. That's the whole thing. You can't really change the rocks and soil. Concrete is porous, so most houses have a concrete foundation. Even if it's not cracked, that radon is just going to move up through the little pore spaces in the concrete. You can't keep it from getting into your house. Once it's in your house, then these air exchange systems can blow it out, or you can leave your windows open or something to dilute that air. So that's what the kit looks like. It's just a little canister. And you see the little slits on the side? That allows those alpha particles, when the radon breaks down, to go into the detector. All the detector is an alpha particle counter. So it counts how much radioactivity is in the air in your house. So this is what the air exchange systems look like. You can see them on the side of the house. It looks like a bunch of PVC. And it's just helping remove some of the radon laced air in your house with outside air. So if you see these on the side of the house, it had high radon levels, and this will help a lot.
My family lives in Fort Collins, and we've got one of those.
You have one of those? Yeah. Yeah, and you can check, and it's dramatically lower. So, yeah. Yeah, I passed on buying a house because, I said, I'll buy it, but you got to put in a radon system. They said no, and I said no. And I bought a different one where the radon levels were really low. Generally, as you move this way from the mountains, the radon levels get lower. Greeley's generally quite a bit lower than Fort Collins. But if you go up in the mountains, radon levels can be really high. Okay, we're going to finish up with this one. This is one I learned about at a conference a few years ago. It's called blue baby disease. You know why it's called blue baby disease? Because babies have turned blue from this and died, sadly. This is a disease caused by toxic levels of nitrate. You guys have probably heard of nitrate. Do you guys know what nitrate is used for in a positive way by humans? There's a specific kind called ammonium nitrate.
Fertilization?
It's fertilizer. Yeah, all forms of fertilizer have lots of nitrates. And fertilizer can be natural, manure, pig crap, cow crap, or you can commercially buy ammonium nitrate and spread it on your field as well. can also be used for bomb making. That's what Tim McVeigh used to blow up the Murrah building in Oklahoma City. It was ammonium nitrate. So nitrate is found in all types of fertilizer, but in high doses, what it does is it affects the respiratory system. Your body picks this up like it would oxygen and delivers it to your cells, but your cells can't use it as oxygen. So it effectively smothers you. You know, if your blood's picking it up, then it's not picking up oxygen. So you're getting less oxygen than you need. And yeah, basically, you can suffocate if you get too much of this. The worst example I heard was at a hog farm in eastern South Dakota, and I'll draw a little picture of it. So here's their farm, and they had their house over here, H, and they had a couple areas for pigs. Okay? So this is looking down from above. Now, if you live in a house, you need water. And this is out in rural areas, so cities aren't providing them with water. So they need to drill a well to get water. And they need water for the household, and they need water for their pigs. Drilling a well is expensive. Every foot that you drill down from the surface costs about 20 bucks. You know, so if you have to drill down 1,000 feet, it's going to cost you $20,000 for your well. How many wells do you want to put in? As few as possible, right? So, and you know, most farmers are not rich people. So they can't afford multiple wells. They're going to have one well. Where are they going to put their well? Well, they didn't give it much thought, so they put the well sort of right in the middle, so they could run water to the house and then water to the pigs. Okay? What do pigs do all day? They eat and they crap. Okay? And if you've ever been to a pig farm, it's not a place that you probably want to spend a terrible amount of time. So these pigs are here and they're just crapping like crazy, right? So this is basically a giant nitrate pit. And that nitrate then soaks into the ground. And it gets into the water. And then where does the water go? It comes out the well and goes into the house. So the residents were actually drinking nitrate-laced water. The nitrates were from their pigs. Sadly, they had a baby girl. And the baby girl was just drinking water. The parents weren't affected by much, but the little girl turned blue and died from excessive nitrate poisoning. You can't taste nitrate. So again, one of those things that caused by human interaction with the ground. Okay, I think we'll just stop with that on that high note. Yeah.
Where should they put the well?
As far away from the pig crap as possible. You know, up here, up here. Just try to get, because this stuff is going to soak straight down. And we're going to talk about groundwater. It's possible for groundwater to suck in things from a distance. So, yeah, we can talk about that. Again, when we talk about groundwater, we'll probably go back and talk about this example. Okay, hope you all have a good weekend. Remember, no class next week. Tuesday. We will have class next week, Thursday.